Hello everyone. In my previous video I did an introduction and listed some components that I'm going to use to make a TDS controller. This is a real industrial TDS control system that I am building. Alright, so I'm just going to go through the components for the sake of those who did not watch my first video. So this is a valve, the TDS valve. That's the one which is going to be opening to flush out water or blow down. This is an LCD. This is a PWM voltage converter. This is just a box that I've set up the terminals. That's Arduino Nano oscilloscope that I'm going to be using to monitor the pulses that are going to be generated in response to TDS change. So those pulses are the ones that we are going to use to drive the valve through this module here, the PWM module. So this is our display. It's going to display everything that is going to be happening to the system. So it will show us everything. This is our simulator, because I'm just doing this on the bench. The design that I'm doing on the bench, so I'm just going to simulate a TDS probe using this instrument here. So stay tuned, let's just follow and go through everything. Just be patient. You might grab one or two things that you might learn, or probably you might also get something that you want to add on in order for us to improve this system. So I always say, when we are working together, it becomes our system. So you are part of the development, so don't feel left out. If you've got any question, you can always ask in the comment section, or maybe you've got another system that you want us to build together. You can always communicate in the comment as well. So if there's anything, or maybe you've got a system that you want us to build together, you can communicate with me and we can talk and see how best we can help each other. Okay, so let's move on. Okay, there we go. The system is booting up. The system is starting up. All right, so for now it's giving us a fault for the sensor. That's the beauty of everything. I've done it in such a way that if the sensor is not there, or is not connected, or the wire is broken, it generates a fault, which shows us that the probe is not connected. All right, so that's the beauty of it. All right, so I've just connected the sensor, which is, in our case, which is just a simulator. So let's look at the screen. You can all see the reading on the screen. We've got TDS, which is about 4850, though around there, and the valve is sitting at 0%, and the system is in auto mode. So I've set it up in such a way that there are options for manual and automatic modes, so you can actually select the mode that you want the system to run. So I haven't put an addition of buttons, but it's there in the code. Everything is there in the code. Okay, so let's look at it. I'm slowly increasing the TDS value. Let's look at the changes that are taking place. You can see the value for TDS is going up. Our set point is 2500 ppm. That's our TDS set point. So you can see the TDS is going up. It's going up, and the valve opening is still 0%, which means our valve is closed at this moment. Okay, and if we look at our oscilloscope, we can see there is nothing, there is no signal displayed on the oscilloscope, which means the controller has not yet started responding to a TDS offset. So we're still waiting for that. We'll continue to push up the TDS. So as it approaches 2000, we should begin to see the valve begin to open. You can see now the valve is now beginning to open. All right, let's look at the oscilloscope. What is it? What is the response at this stage? So you can actually see that the oscilloscope is responding in step with that increase. So the system has already detected a rise in TDS. So it has already started to correct TDS. Let's continue to push it up. You can see the valve is opening more. The valve is opened 3% now. The valve is opened about 3%. Let's look at the signal. You can actually see the pulse width is actually increasing, which means our system is responding to the changes that are happening to TDS. Let's continue to increase the TDS because we still haven't reached the set point of 2500. We just want to see what's going to happen there. Now we are really approaching about 2000, and let's look at our oscilloscope waveform. So those are the pulses that we are getting from the oscilloscope. So it shows that the system is responding. So this signal that we are getting from the oscilloscope is the same signal that we are going to use. That's the same signal that we're going to apply to this module, and in turn to this controller to adjust a blowdown. All right, so that is what will be happening. So those pulses will be converted to voltage. That's basically what it is. So let's continue to increase TDS because we still haven't reached the set point. All right, so it's going up, and you can actually see the valve opening is also responding in step with the change that is happening. We're now sitting at about 2600, and let's see our response, the pulses that we're getting from the output of the controller, or the controller controlling the valve. So basically that's the signal that is controlling the valve. So at this stage it means the valve opening is basically set to about 34%. So the opening is there to improve the quality of the boiler water, so it has to blow down, it has to discharge water, right, in order to correct TDS. So this is how the system works. I'm just gonna continue going up. Let me just go up, and then we see what's going to happen to the valve at this stage. Now the valve is opened 34%. All right, the valve opened 34% now. Let's just see what's going to happen if we continue to go up, so that we see how the system works. This is a real industrial TDS system. This is how it behaves. The real industrial TDS industrial system. Right. Just wanna continue to push it up and see what's gonna happen. Let's see what's going to happen. Let's look at the signal, what is happening there. You can see the width is increasing and increasing and increasing and increasing and increasing. Let's look at the percentage. We are now sitting at 89%. So the valve is now opened 89%, right? At this stage, it's almost close to 100% open. Now look at the signal there. So this is how the system works. So if correction begins to take place and probably TDS begins to lower down, let's see what's going to happen. Let's look at our signal as well. So you can see the power switch is also changing in step with the change in TDS. The valve opening is also responding in step with that. I think we've achieved here, guys. What do you think? Just tell me in the comment section. The valve is open 0%. TDS is low. So blowdown is fully stopped now to improve TDS, right? You can see there is no signal now to drive the valve at this stage. Okay, guys, so this is our system. This is how it works. This is what we have done. So if you have got any contribution or anything that you want to add, let's talk in the comment section. Or if you feel there's some form of improvement that you would want us to do to this system, let's build this system together. Or if there's any other system that you want us to build together, let's talk in the comment section. So thank you so much for following, for watching. Thank you so much for subscribing. We are going to be showing more of practical industrial systems. Or if you've got a system at your workplace that is giving you problems and you want us to talk or discuss the problems or something that you want to be improved or built, let's talk in the comment section, and you can always find methods of going around it. Thank you so much for watching. Don't forget to like, to subscribe to this channel. Thank you.